The next step we are going to take is to learn about functions and methods. Functions are incredibly useful because they help you to automate a lot of things. We already encountered functions, like for example the print function. And these so-called built-in functions that are already defined in Python, are basically pre-written algorithms that take an input that we usually call an argument, and they perform some computation on this input and then return an output. There are a lot of built-in functions in Python, but it is actually very helpful, useful, and also quite easy to write your own function. We will now learn how to write a function via an example. Now, this is a very simple function, but it actually consists of all the parts that usually functions have. First of all, if we want to define a function, we have to tell Python that now what comes now is actually a function definition, and we do this by using the keyword def. It indicates that everything that comes after belongs to a function definition. The first name that comes after def is the name of the function. So the function we are defining here is called test function. You can see this if we execute the code and then write test function and press enter. Then basically Python tells us in this very particular way that we here deal with a function. The next thing that comes in the square brackets are the so-called arguments of the functions. This then is later how you can pass inputs to the function once you call it. In this example, the function has two arguments, x and y. If we call the function test function with 3 arguments, actually Python will throw out an error because it only takes 2 arguments. If we pass the right number of arguments to the function and press enter, then the function executes what is written in the function body. The colon that comes after the arguments indicates the end of the so-called function header, which consists of the def keyword, the function name, and the arguments. Then what comes here is the so-called documentation string, or the doc string. It basically describes what the function does. And it is something that you should definitely do if you write your own functions, if they are not as immediately clear as this function here. And in the script to the video, you actually find a nice manual of how to write good doc strings. And I really recommend you to do that because that helps you to understand better what you're actually writing, and it helps you to get back into your code if you've left it for 2 weeks and then you come back working on it. If you haven't written any doc strings, it's very hard for you to actually understand what you've been doing before. Now, after the doc string comes the function body, and the function body is actually the most interesting part of the function because here you write the code that specifies what the function does. Here, note that actually within the definition of the function that the indentation is very important. That's a particular language feature of Python. The function body basically specifies what the function does. So in this case, actually what the function does, it takes the 2 arguments, sums them up, and transforms the result into a float, and binds it to the name result. Then in the final part of the function, actually everything that comes after the return statement, that specifies what the function actually returns. And in this case, it returns, the result of the addition of x and y transformed into a float. That is also what we see here. If we call the test function with the 2 arguments 5 and 9, what do you think comes out of it? Well, yeah, obviously 14. Now, what is very important here is that everything that happens here within the function body stays within the function body. So we say that this function body here defines its own namespace. What does it mean? In the function body here, we associate the result of x plus y transformed into a float with a name result. If we call the function here and then ask Python about the result, it tells us that the name result is not defined. And this is because everything that happens here within the function body gets executed, but once you leave the function, it gets removed from your workspace. It's not there anymore. This is very useful because think of very complex functions that do a lot of stuff where you have a lot of variables defined. And if they would carry this with them after they are completed, it would be an incredible mess in your workspace. So that is actually extremely useful. We will now learn a bit about methods. Methods are very similar to functions. And to fully grasp what a method actually is, you have to understand that everything in Python is an object. We will learn more about objects when we learn about classes, but we will preview some of the content at this point. Everything in Python is an object. Primitive data types, containers, functions, everything. Everything is considered an object. And all objects have two major components, attributes and methods. Methods are basically functions that are called from within the object and take the object as their first argument. Methods are usually used to perform operations that are very common for the specific object at hand. It's probably best to look at this for an example. Let us define a list. Now, something that is very common to do for a list is to append things to it. And because this is very common for the data type list, there exists a method that does exactly this. In order to apply a method to the list1 here, we have to write the name of the object, list1, then add a point, and then we already here get some suggestions of methods that we can use. Let us call the method append and call it with the argument 5. What the method does, it actually takes here two arguments, but the first argument is implicit, and the first argument is here list number 1. If we execute this code, we see that it seems to be that nothing has happened, but that is actually not true. Methods do not return a value immediately, but if we call list1 now, we actually see that the integer 5 has been appended to the list. Another thing that is very commonly done with the lists is to sort them. So there's also a method called sort, and if we call this method, we do not necessarily need to pass an argument to it. It implicitly takes one argument, which is the list itself, and if we call this method, and if we then call the list1 again, we actually see that the list is now sorted. There's something called an optional argument, an argument that we can give to the method sort, but we do not need to, and that is the argument called reverse. If we want to use these optional arguments, it's usually better to write them down there directly and then pass the value for them explicitly. If we want to say to Python that the list should be sorted in reverse order, we tell Python call the method sort, and set the argument reverse to true. If we call this method and then look at the list, we see that it is now sorted in reverse order. In the script, you find a number of common methods to be used with lists, and you will notice that all these methods refer to actions that are very common for lists. That is why these methods exist. We now turn to so-called if-else statements. These statements are very convenient and they are very frequently used, in particular in agent-based modeling. It's best to work through it with an example. Let's associate x with 4 and then write an if-else statement. You start an if-else statement with the keyword if, and then you have to add a logical test. So for example, we might ask Python whether x equals 2, and in case this is true, Python should print x equals 2. To do this, we ask Python whether x equals 2, and we add a colon. It is very important to be careful that this indentation here is not removed, because Python is very restrictive with regard to the indentations. And then we write what should happen if x really equals 2. So in this case, actually, we want Python to print the string x equals 2. If we execute this code, nothing happens. Why? Because here the if condition is not fulfilled. If we set x to 2 and we run the code again, then prints x equals 2 because this condition here is fulfilled. We can write more complex if-else statements by adding further conditions, so with the keyword elif. The elif actually allows us to add an additional if statement that is only tested if this first if statement is false. If this if statement is true, Python will ignore all further elif statements here. Now in this case, if we execute the whole code, as expected, Python will print exactly this part of the if-else statements that is intended under the condition that is true. Usually, you should always end every if-else statement with an else. An else keyword, the else keyword is not followed by a condition, because everything that comes after else is executed if none of the if or elif statements has been true. So in this case, actually, we have exhausted all possibilities, so what comes after the else statements will never be executed. But in case, for example, we remove this part here, and we set x to greater than 2, and we execute the whole thing, then actually we see that Python prints what comes after the else statement. It's also very easy to nest if-else statements. You see some examples in the scripts, but the basic structure and the basic syntax will be exactly the same. Very related to if-else statements are assertions, and assertions are very useful because they allow you to test whether certain conditions are true or not. So for example, consider we have this list X. And for the further processing, we actually want to assume that this list is not longer than 2. Then we can write an assert statement by writing the asserts keyword, and then providing a logical test. And if we execute this, and the condition after the assert keyword is not fulfilled, Python will throw an error. This is very useful if you want to test, for example, in the beginning of a self-written function whether the arguments fulfill certain conditions. And in order to increase clarity, it is also useful to add here a particular error message that is informative. And this error message gets printed if the assertion is wrong. So in this case, we immediately understand actually what is happening. The list is too long. And this way, it is much easier to actually write understandable code.